everybody. In this video, we're going to talk about how to identify the formulas that you should use when you have a mixture of word problems that come from any of the 4 sections of formulas that we've talked about in this unit so far. So take 3 deep breaths and let's make this math easy. Okay, so far in this unit, we have looked at 4 different categories of formulas. So we've looked at simple interest formulas, compound interest formulas, savings annuities, as well as loans. And your assignments in class have been focused on each one of these sections individually. On your assignment for today and also on your test, you're going to have a mixture of word problems that fit into all 4 of these categories. And so you need to know how to figure out which category the word problem fits into so you know which formulas to apply. So that's our goal for today. We're not learning any new formulas. You're not going to have to do any new types of calculations. The main goal for today is figuring out which category the word problem fits into. So to do that, I've given you 3 questions that can help you narrow down and essentially eliminate the categories one by one until you narrow it down to one category. So the first question that you can ask when you're reading through a word problem is, does the word problem say simple interest somewhere? You know, it might say that there's a simple interest rate. It might say that the interest is calculated on a simple interest rate of this, but you're looking for the word simple interest. And if it does say simple interest, then you can just know that it's the simple interest category because those formulas are the only ones that calculate the interest where you're only earning interest on the amount you invest or paying interest on the amount you borrow, but you're not having to earn or pay interest on the interest, if that makes sense, because that's how compound interest works. So if it says simple interest, you automatically know that it's going to be this category. If it does not say simple interest, that means that the interest is compounded and it's going to be one of the other 3. So this is really important because sometimes people think if the problem says that the interest is compounded, that you should use the compound interest formulas. But that's not necessarily the case because this part of the equation is the part that calculates the compound interest. And that part of the equation also shows up in savings, annuities, and loans. And so even though savings, annuities, and loans don't have the words compound interest in their title, they are still compound interest. And so if the problem says that the interest is compounded, it could be any one of these 3 categories. So if the problem does not say simple interest, you know it's got to be one of the other 3, but it could be any one of the 3, even if the word problem says that the interest is compounded. So let's say, for example, we're reading through a word problem and it doesn't say simple interest. So we know that it's compound, and we can eliminate this section because it doesn't say simple interest. So now we only have 3 categories that we need to narrow down. So the next question can help us narrow down narrow it down one more, because the next question says, is it a loan or an investment? If it's a loan, it could be the simple interest, it could be compound interest, or it could be loans, but it can't be savings. And similarly, if it says that you're investing it or saving money or something like that, then you're not going to use the loans formula. So question 2 will help you eliminate either this section or this section. So let's say we're reading through the problem and it's a situation where you're borrowing money to buy a house. In that case, it's obviously a loan situation, so we would eliminate the savings annuity section. And then the last question says, are you making one-time payments and deposits, or are you making repeated payments or deposits? So if it's a one-time situation, then it's going to be either simple interest or compound interest. And since we've eliminated simple interest in this hypothetical word problem we're thinking about, then we would use the compound interest formulas. In the word problem that I randomly made up, where we're buying a house, it's probably not very likely that you're going to pay off your house all at once. Like no bank is going to give you a loan where they're like, oh yeah, just live in the house for 30 years and then you can pay us back at the end. No, like they're going to make you pay on a monthly basis. And so that would mean that you could eliminate the compound interest where you're making a one-time payment at the end of the loan. And you would say that you're going to use the loans formula. But maybe if it was like a short-term loan, like you're only borrowing the money for a year and you're borrowing it from a friend, in that case, if you're paying back all of the money at the end, then you would use the compound interest formula, because the compound interest formula and also the simple interest formulas are all based on either paying all the money back at the end or investing all of the money up front, where you're not making monthly deposits or payments. So that's a brief overview of how these three questions work. So let's go ahead and work through some examples to see how this would go. So on this question, it says, if we want to have $21,000 saved by the end of 4 years, how much should we invest now at an interest rate of 8% compounded monthly? So as I read through my word problem, it doesn't say simple interest anywhere, and it actually says that my interest is compounded monthly. So that means that I can eliminate this section of my table because it didn't say simple interest, so it's not going to be the simple interest formulas. And it said that the interest is compounded, and that could be any one of the other three sections. So my next situation, or my next question I'm going to ask is this a loan or is it an investment? And it said that we're saving, like our goal is to save $21,000 by the end of 4 years. And so that means it's definitely not a loan. So I can eliminate the loan section. And then on question 3, it says, are we making one-time payments and deposits, or are we making repeated payments and deposits? So reading through the problem, this sentence right here where it says, how much should we invest now at an interest rate of 8% compounded monthly, that's my clue to tell me that I'm investing a whole bunch of money right up front. And so that means that this would be a compound interest situation. Because if it had been a savings annuity situation, the word problem would have said, how much should you invest every month at an interest rate of blah, 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 in order to reach your goal. So the difference is whether you're making a one-time investment where you're paying a whole bunch up front, or whether you are making repeated investments. So once I've identified my formulas, then I can plug in all my variables. And it's actually really helpful to identify your variables even before you do this process of asking the questions, because the variables themselves can help you figure out the formulas as well. For example, if I was coming to this problem fresh and I didn't already know that it was a compound interest formula situation, I could say, reading through the problem, I've got 21,000, 4 years. I'm trying to look for how much I should invest now. My interest rate is 8% and the interest is compounded monthly. I could go through and identify my variables and say, okay, well, T equals 4 years. My interest rate is 0.08 and it's compounded monthly, so K equals 12. And then the 21,000 is the amount I want to have saved by the end of 4 years. So that tells me that A equals 21,000. And the amount that I'm looking for is how much should I invest now, which is my beginning amount. So P is the thing that I'm looking for. And if you look at the formulas, the loans formula if you look at that, doesn't involve A at all. So that's kind of a clue that we wouldn't use the loans formula. And similarly, the savings annuities formula doesn't have a P anywhere, and that's what we're looking for, so we wouldn't use the savings annuities. Simple interest has A and P, but it doesn't have K, which is our compounding frequency, and so that tells us that we wouldn't use simple interest. So sometimes identifying the variables can help you figure out the formulas without having to even ask the questions. So that's why I wanted you guys to practice writing out the variables in your assignments earlier, is because identifying those variables correctly can help you figure out which formula to use. So that's another strategy for finding the formula. So if you want to plug these numbers into the formula to just practice calculating that again, you can pause this video and do that right now, and then restart the video to see what the correct answer is. Okay, so when you plug these numbers into the formula, you should get 21,000 equals P times 1 plus 0.08 divided by 12 raised to an exponent of 4 times 12. And when you simplify this using order of operations, you'd start with the parentheses, simplify the division, add 1, and then raise that result to an exponent of 48. And when you do all of that, you should end up with P times 1.37566 or actually there's 3 sixes, 1, and that decimal technically keeps on going even longer than that, and your calculator should store that. So that's what you get when you simplify the stuff in parentheses raised to the exponent. And then to solve for P, you're just going to divide by that decimal on both sides. And when you do that, that gives you that P equals $15,265.33. So that should be the answer that you got for P. And that's how you would do that question. So let's go ahead and do another example here. So I'm going to identify my variables as I read through the problem, and then I'm going to use the questions to figure out which formula to use. So in this problem, it says, suppose you want to have $2.5 million saved for retirement in 40 years, and if the account earns 5% interest, how much would you need to deposit monthly in order to meet your goal? Okay, so the 2.5 million is the amount I want to have saved for retirement in 40 years. So that means that that's my ending amount, or A. So I can identify that. And then the amount of time that I'm saving this for is 40 years. So that's T. And then the interest rate, or R, is 5%, which written as a decimal is 0.05. And then the question asked, how much would you need to deposit monthly? So that means we're looking for D. That's the variable we're looking for. And then the fact that we're depositing it on a monthly basis means that K equals 12. Because remember, the deposit frequency has to match the compounding frequency of the interest. So that's identifying all of my variables. And if you looked at all of those variables and looked for a formula that includes all of those variables, you would know that the formula section we need to use is the savings annuities one, because that's the only set of formulas that involves A, T, R, K, and D. But you can also reach that conclusion by going through the questions. So you can say, does the word problem say simple interest? Well, no, it didn't say simple interest anywhere, so we can eliminate that section. Then we say, is this a loan situation or is this an investment? Well, we're saving for retirement, so that means it's not a loan. It's going to be a savings situation, so we're going to eliminate loans. Now remember, it could still be a savings situation where you are investing your money one time and you're investing a whole bunch of money and then it just sits in the account for 40 years. In that case, it would be compound interest. But in this problem, we were asked how much would we need to deposit on a monthly basis, which means we're making repeated investments. And so that's what eliminates compound interest and tells us that it's going to be the savings annuities formula. So that's how you would do or identify the formula for this word problem. So pause this video, practice plugging in these variables into the formula, and then restart the video to see what the correct answer would be on that. Okay, so when you plug all of these numbers into the savings annuities formula, you would end up with 2.5 million equals D, which is the variable we're looking for, times 1 plus 0.05 over 12 raised to an exponent of 12 times 40, which I'm just going to simplify right now to be 480, and then minus 1, and all of that's divided by 0.05 over 12. Okay, so that's the formula that I would be simplifying. And when I simplify it, I would start off by finding my innermost set of parentheses and simplifying that. So I divide 0.05 by 12, add 1, then raise that result to 480, take that result and subtract 1, and that would give me all of the stuff in this big set of parentheses. Then I would take that result and divide by the division of 0.05 divided by 12. And remember to put that in parentheses when you type that into your calculator. And once you've simplified that whole fraction section here, you should end up with D times 1,526.02, and this decimal keeps going, and that equals 2.5 million. And so to figure out what D is, you would just take both sides and divide by this 15,026 decimal number. And when you do that, 2.5 million divided by my answer that I found is going to tell me that D, or my monthly deposit, needs to be $1,638.25. And so that would be my calculation for D. And that's how you would do that one. Okay, let's do another example of identifying the formula here. And if you want to, now that we've kind of gone through a couple of examples, you can pause this video and see if you can figure it out yourself, and then restart it to see if your thought process is correct, or you can keep working along with me. That's up to you. Okay, so as I read through this word problem, I'm going to identify my variables. So in this problem, it says, suppose you have $95,000 in your savings account after a certain amount of time, which they didn't tell us, when you've invested $70,000 at a 4% simple annual interest rate. And the question is how long was your money invested? So I'm going to write out what I'm looking for to start with. So T is the thing I'm looking for. The $95,000 is the amount I have in my savings account after the amount of time that I've invested my money for. So that tells me that $95,000 is going to be my variable A. And the amount that I invested was $70,000. And that's obviously going to be a one-time investment because they didn't say I invested $70,000 every month. They just said I invested that amount. And also, like, $70,000 a month would be an insane amount to invest. Like, most people don't make $70,000 a month. So that tells me that P is the 70,000 number. And then the interest rate is 0.04. And so those are my variables. And this problem's really easy to identify which formula section it is because it says simple annual interest rate. And so that automatically means that we're going to be doing the simple interest section. And we could also figure that out just from the variables because all of the other sections require a K, like compound interest, savings, annuities, and loans all need to know what K is, which is the frequency that you're compounding the interest at. And in this word problem, it didn't mention anything about anything happening monthly or quarterly or weekly or anything like that. It just said that we invested $70,000. And so that's how we know that it's simple interest. So go ahead and try plugging this in to solve for t, and then restart the video to see how I would solve it. Okay, so on this problem, when you plug in your numbers, you get 95,000 equals 70,000 times 1 plus my interest rate, 0.04, times t. And by the way that I knew to use this formula and not this one is because I know what A is, and I wasn't given I, and so that's how I knew to use the first formula. So when I plug those numbers in, if I knew what t was, I would be able to simplify it because order of operations says I would start with the parentheses, and inside of the parentheses, I would need to do the multiplication first. However, I don't know what t is, and so I can't simplify the multiplication, so I can't simplify anything else in the expression because that would be my first step of simplifying. So what I'm going to do instead is I'm going to use the order of operations to help me solve the equation. So if I knew what t was, I would multiply by 0.04. Then I would take that result and add 1 to it. And then I would take that result and multiply by 70,000. So to solve this equation, I'm going to work backwards and undo each one of these operations. So to undo the multiplication by 70,000, I'm going to divide by 70,000. And that cancels out the 70,000 on the right side, which gives me 1 plus 0.04t. And this is equal to, if I do 95,000 divided by 70,000 in my calculator, I get 1.3714, etc. So I'm just going to write out part of that decimal, but I would recommend you keep the whole decimal. And then to undo the next step, so now I'm undoing this plus 1, I'm going to subtract 1 from both sides, which gives me 0.37 or 357, etc. Equals 0.04t. And then to figure out what t is, to undo this last step, I'm going to divide by 0.04. And that tells me that t equals 8.928. And in your test, if you have a problem like this where you have a decimal number for the number of years, I will tell you specifically how many decimal places to round it to. But that would be the value for t. And that's how you would do that question. Okay, so here's one last example that we'll go through. So on this one, the problem says you want to buy a house and you can afford payments of $1,600 per month. The bank is offering a interest rate of 7% compounded monthly. And if you get a 30-year mortgage, how much interest will you pay in total by the time your house is paid off? Okay, so in this problem, the $1,600 is our monthly deposit. The interest rate is, or the bank is offering an interest rate of 7%, so that's 0.07 for R. The fact that it's compounded monthly tells me K equals 12. Also, this fact also tells me that K is equal to 12 because I'm making my payments on a monthly basis. And then the amount of time is 30 years. And the question I'm asked is how much interest will I pay? So in this case, if you look through all of the formulas, there's not any formula that involves I and D and R and K and T. But the questions that we can ask will help us figure out which section the formulas are in. So let's go ahead and go through those. So on question 1, it says, does the problem say simple interest? Well, no, it actually specifically said the interest was compounded So that means we can eliminate the simple interest situation. Then we can say, is this a loan situation or is this an investment? Well, we bought a house and we're paying off the house, so that means it's a loan situation, and we can eliminate the savings annuities one. And then to figure out if it's compound interest or loans, we ask ourselves, is this a situation where you make the payment all at once, or are you making repeated payments? Well, if you're making a payment of $1,600 per month, that's a repeated payment. And so that tells us that we would use the loans formula and not the compound interest formula. So in order to find the interest, notice that the interest formula requires us to know D, K, and T as well as P. So we know D, K, and T, but we don't know what P is. And so we would want to use this formula to find P and then use that result here. So that's why identifying the variables wasn't necessarily helpful, because all of the formulas involve I, but the way they calculate I is different. And so in this case, we had to use the questions to figure out which section we were doing our calculations in. But our formulas or our variables could have helped us eliminate the simple and compound interest situations, because we know what the variable D is, and neither one of those situations has a D in it. So you could have eliminated simple and compound interest from that, and then realized that this isn't a savings situation, it's a loan situation, and that would be another way you could have identified that formula. But anyway, I'll let you guys pause this video to practice plugging in the numbers and finding out what I is, and then restart this video to see how I would solve it. Okay, so when you plug all of these numbers into the formula to find P, you'll find that P equals 1,600 times 1 minus 1 plus 0.07 divided by 12 raised to an exponent of negative 360, because that's what 12 times 30 is. And then this is all divided by 0.07 divided by 12. And when you plug all of that into your calculator, you would start with the innermost set of parentheses, simplify the division, add 1 to that, then raise it to the negative exponent, and then make sure you do 1 minus that result, not that minus 1, because that will make it negative. But you'll do 1 minus it to get the big set of parentheses on the top of the fraction. And then you can either multiply by 1,600 or divide by the stuff on the bottom. In either case, after you've divided by the stuff on the bottom and multiplied by the 1,600, you're going to get that P equals $240,492.11. And then to find the interest, which is ultimately what we're looking for, you would take the total amount that you've paid into the account, which is going to be your monthly deposit, times 12 months, times 30 years. And that result, let's see what that is, 1,600 times 12 times 30. That is going to be 576,000, so 576,000. So that's the amount that you used to pay off the house, but the amount that you originally borrowed to buy the house was $240,492.11. And so you subtract that amount to see how much interest you ended up paying. So I'll take that number, subtract $240,492.11, and that tells me that my interest is $335,507.89. And so that would be the answer to the question that was asked here. Now, on your test, I will give you guys problems where you'll be asked to find P, and then you'll be asked how much you paid to pay off the loan, and then you'll be asked to find interest. So you're not going to have any questions like this one where you just have to find the interest. It'll kind of give you all of the parts you have to find in order to get the interest. But this is how you would solve a problem that's asked like this. So that's it for today's video. For you guys to practice using or figuring out which formula to use, I want you guys to go through the identifying formulas assignment in your packet. And you don't have to solve the problems yet. You can do that with your group in class. But I want you to go through and see if you can figure out which one of the 4 categories of formulas you would use for each question. And then check and compare your answers with your group members when you get to class. Because practicing identifying the formulas on your own is going to be really, really important for you to succeed on your test for this unit. So if you have any questions, let me know. And I hope you have a good day.